Okay, hello everybody. I'm going to go through all of the solutions to the sample final exam. And so here we go. So number one, which number is irrational? The number that is right here, this radical 5. Any number that's not a perfect square is a crazy decimal that never ends or repeats. So any number that's not a perfect square. Number 2, this is radical 6 plus, and the square root of 81 is actually 9, but we still have this radical 6, which we don't, that's not a perfect square, so the difference is just actually subtracting those two. Sorry about that. And so that would be an irrational number still. Number 3, right now it's 120 miles per hour, so we want to convert that. So we write 120 miles per hour, and then we multiply. We want the result to be in, we can see right here, we want the result to be in miles per minute. And so I'm going to try to see how the miles is already in good shape. So miles, but the hours needs to be changed to minutes. So I need to multiply by 1 conversion. So 1 hour is the same thing as 60 minutes. Notice I put the hours on top so that they cancel with the hours right here on the bottom. And I just multiply straight across. So this would be 120 miles for 60 minutes. And then I can reduce that, and that would be 2 miles per minute. So that would be B. Number 4, 8 miles per hour. So we write 8 miles, so same as the last one, and it'll just require more conversions. More conversion factors that we multiply by. So we want to change the hours to, we want the goal is to have it in feet per second. So off to the right, we can say what the goal is. We want it to be in feet per second. We know we need to change hours into seconds, so we start multiplying by some conversion factors. So 1 hour is the same thing as 60 minutes. The hours will cancel out, but it's still not good enough, so we want to multiply by another conversion. 1 minute over 60 seconds. The minutes will cancel out, so we're going to be in good shape for the seconds. Then we're going to use this conversion for the miles and the feet. So let's put 1 mile on the bottom, 5,280 feet on the top, and then just multiply straight across. So when I did this, I got 42,240 on the top, and then on the bottom I got 3,600 seconds. And use your calculator to reduce that, and it's 11.73 with a bar over it, feet per second. So it looks like the closest answer there is 12 feet per second. Which one of these would be the right answer? I would say probably the height of a plane. You know, you figure in the beginning it's going up, it's raising its height, and then it gets to its cruising altitude, so it'd probably stay like this. You can debate probably these other ones. The height of a person over a lifetime, you could say they're growing, you know, in the beginning of their lifetime, and then they reach their height. So you could probably make an argument for A or B on that one. The other ones don't make much sense. Number 6, okay, this one looks like 40 kilometers is going to be this one right here, 40 kilometers. You can see that in 1 hour that the bicyclist was able to cover 40 kilometers. And then since they were only going for another 30 minutes, then they were able to only cover 20 more kilometers. And then it says he took a 30-minute rest, so that would show flat line right here for 30 minutes. And then the next is he just continues on his journey, and we're assuming, pretty much the same rate. So you can see it looks like it's, pretty similar right there. Let's see, 40 kilometers. So it doesn't really say what the speed is for the rest of the journey, but that's the only one that's correct up to that point. Number 7, we're mainly looking at scale here, to see if you were graphing this information, what you would use for your x-axis scale and your y-axis scale. And so the one that would really work out the best would be this one here. Time is always on the x-axis, and then population would be good for the y-axis, and then in thousands this would be pretty good scale. So the first one, it would be at 3,500, so we'd put a dot here. Not that you have to graph this or anything, you're mainly, again, just looking at which scale would be the best, so I'd pick that one. These other ones aren't as good. This one's in 10 thousandths, so that's too big. Now this one should say, this should say age, so at least it's consistent. 3 years younger than Sam, which the following could be Sam's age. So there are a couple different ways you could do this, but the way that this is listed because of these answers is that if Sam, so let's say you have these two guys' ages, if you let Raul be R, and you know that Raul is 3 years younger than Sam, that would of course mean that Sam is 3 years older. And so if you let Raul be R, that means that Sam would be R plus 3, and it's looking for an expression for Sam's age. So you could go ahead and let this be Sam's age. You could also do it a different way. You could do, so I'm going to put an or here. You could say that Sam was R, and then Raul would be 3 years younger than that, and so Raul would be R minus 3. But since they're looking for an expression for Sam's age, Sam's either R plus 3 or Sam's R, and it's neither of these, and so that's why I'm figuring that we're going with this route. Okay. Which of these would be a good equation if you wanted to solve this? Well, the way I would see it is that if you thought of this as Jen could be 2x, and then Daniel would be x, and this is half of this. Another way of saying is that whatever Daniel sold, Jen would sell twice as much. That's the same thing as saying that, if you could also do it this way. If Jen was x, then Daniel would be 1/2 x equals 90, and you should be able to solve it that way as well. But this one doesn't have any of those options, and so we would choose this one. Domain and range, just need to remember that domain are all of the x's and the range are all of the y values. So this is your domain, and of course this would be your range. So you just look for the answer that looks the same as that. So that would be A. Same, except just more real-world context. So for this one, it would be A, because we're talking the months are the domain, and the pounds are listed there as the range. Which graph's not a function? Anything that doesn't pass the vertical line test, meaning any vertical line that passes through the graph more than once is not a function. So this one does not pass the vertical line test. So I'm just going to make a little note, vertical line test. So all these other ones pass the vertical line test. Okay, for this one, I'm going to show all the work here. We got to plug in, the notation is g of negative 3, which shows that you're taking a negative 3 and you're plugging it in for all of the x's. So 3 times negative 3 cubed minus 7, negative 3 squared, minus 2 times negative 3 plus 6. Okay, so this one here you have to do exponents first. So it's negative 3 cubed, which is negative 3 times negative 3 times negative 3. So this is going to turn out to be negative 27 minus 7. And then this is negative 3 squared, which is negative 3 times negative 3, which is 9. And then this is a negative and a negative, so this is going to be a plus 6, and then plus your 6 here. So let's keep showing the work. So negative 27 times 3, negative 81, minus 63, plus, and you add these together, 12. Keep going, and we would have negative 132. So this one here, B. 14. On this one, I would take these x values and plug them into each of these functions to see which one it satisfies, which one works. So the one that I see works is D, because if you take a 1 and you plug it in, it would be 2 times 1 plus 1, and it actually equals this f of x, this y value. Just think of these as y values, x and y. So you can see that would work, and then it has to work for the whole data table. So 2 times 2 is 4, plus the 1 gives you 5, so it works for that one. 2 times 3 plus the 1 gives you 7, so it works for all of them. Okay, solve this. We want to add 8, so this would be 5x equals 18, divide by 5, x equals 18 over 5. So this one. Okay, so this one we're going to distribute, so we'll have negative 4x plus 12 minus 2x equals 36. And then we want to combine like terms. So we have negative 4x minus 2x, which is negative 6x, plus 12 equals 36. And then we want to subtract 12. So negative 6x equals 24. And then divide by negative 6. So x equals negative 4. So that would be C. Okay, this one will probably seem really hard in the beginning. We just want to get the h by itself. So we basically need to get rid of all these letters. We're just trying to isolate the h. So what you can do right off the bat is you can multiply by 2. If you multiply by 2, then that actually will cancel this 2, and it'll leave you with 2a equals b sub 1 plus b sub 2 times h. And then, if we want to get the h by itself, we can just divide by this whole quantity, b sub 1 plus b sub 2, and that will isolate the h. So that will cancel all this. And we'll have h equals whatever's on the left side here. So that would be 2a divided by b sub 1 plus b sub 2, which it looks like that would be b. Okay, this one is 500 people they can hold, so that's less than or equal to. And then so far they have 320 people in the gym. So 320 plus however many other people want to enter has to be less than or equal to 500. This one we want to get the n's together, so just subtract 6n. So that would be 2n is greater than or equal to 12, then divide by 2. So n is greater than or equal to 6. And that would be, looks like, A. Number 20, we want to subtract 15. So that would be negative 5d is less than 15. And then divide by negative 5. Remember, when you divide or multiply by a negative number, you have to reverse the inequality here. So greater than now. So d is greater than... Actually, this one should have had a bar underneath it right at the beginning. So d is greater than or equal to negative 3. So 20a. 21, we just want to, we know that this is a solid boundary, so we can pretty much cut off the ones that don't have a bar. And then we want to do a test point to see which side we shade. So let's do 0, 0 as the test point. So we're going to plug it in. So let's plug it in to this inequality here. Well, we have to figure out which one it is. So let's try this one here, see if it works. So it would be 0 is greater than or equal to negative 3 times 0 plus 4. 0 is greater than or equal to 4. That is false. And so we would want to shade the other side, which it's going to be this one. So this would be false, and so it's 21, it's B. Okay. This one is $50 plus $70 an hour. It's $70 for every hour of work. So you have your $50 fee plus your $70 per hour. So it's B. Pardon me. 23, which ordered pair is not a solution? So we would just look to see, we can see 2, 2 is a solution. 3, 1, we can see that one. Negative 1, 5 is on the line, that's good. So 0, negative 4 is the only one. You can either see from the graph, or you can just plug it in to the equation and see if it satisfies the equation. Okay, we're looking for a graph that has a y-intercept of negative 1. That one doesn't. That one doesn't. So it's one of these. And then it has to have a slope of negative 1/4. So that means, remember, rise over run. It has to go down 1 and over 4. So it looks like it's this one. Down 1, over 4. So that would be C. Ooh, it's like that. Okay. X and Y intercepts. So we can do cover-up method on this, or we can just show the full work. So x-intercept is when you set the y equal to 0 and solve for x. So let's actually plug in a 0 for the y. So that would be 3x minus 4 times 0 equals 12. 3x equals 12. X equals 4. Remember, we put a 0 in for the y, so that's 4, 0 for the x-intercept. This one only has one choice that has that. And then the y-intercept, plug in a 0 for the x. And then you can divide by negative 4 on both sides, and you'll get the y-intercept here. So B it is. 26, we're looking for which one of these would correctly give us the slope. There probably are a few that look similar. The only one that's totally correct is this one here, because they did the 4 minus the 0, and then they did the 0 minus a negative 2, which will turn out to be 0 plus 2. 4 over 2 is 2. All these other ones have little mistakes along the way. This one has 8 minus 2, and then it switches the order, and it starts with 3 over here. So you have to be consistent. And then these other ones are, good processes if they did it right, but they made mistakes along the way. You can take an equation and then solve it for y and tell that it's this number, but let's see. This one, what did they do wrong? They forgot, when they subtracted the 4x, they forgot to carry this little negative sign. So what did I say? 26 is C. The y-intercept, so this one's pretty quick. It's already in slope-intercept form, so 0, negative 3. 28. Okay, this is a good one. Whenever you have a point and a slope, you should use the point-slope method. So y minus y sub 1 equals m times x minus x sub 1. So y minus 2 equals the slope, and then x minus a negative, so that's going to be x plus. And then we want to distribute. So negative 2x minus 8, and then we'll add 2 to both sides. So we have y equals negative 2x minus 6. So that looks like this one, D. This one we have to find the slope first. So we're going to subtract the y's. So that would be 13 minus 7, and then 1 minus 4. 13 minus 7, that's 6. 1 minus 4 is negative 3. So that gives me a slope of negative 2. And then I can pick a point, and I can do the same as the last problem. Y minus y sub 1 equals slope times x minus x sub 1. Y minus the y coordinate equals the slope, x minus the x coordinate. Distribute negative 2x plus 8 because of the two negatives, and then add 7. So we have y equals negative 2x plus 15. So that would be this one. I would say, looking at 8 years, it looks like it'd be about here. So I would say 38,000 would be the closest. Correlation coefficient has a negative slope here, so it's going to be a negative number. It is really close to negative 1. It's almost a perfect line. It's not a perfect line. If it was, it would be negative 1. But since it's pretty close, negative 0.9 is the best choice. If it's in the positive direction, then it's going to be a positive number. 0.9 would be if it was really similar dots going up like this. And then 0 would be terrible, dots everywhere. I don't really think this one has a good answer. Cause and effect, it means that if this happens, then so does this. The closest one is maybe this B, but to be honest, even that, the temperature does not directly affect the number of snow cones sold at the fair. So I'm going to say none of these are good. Okay? So what would I bubble? If I had to bubble something on this, I'm gonna say nothing. Okay, number 33. The best answer, the only answer, is A. And the way you graph this one, you can tell the y-intercept is 2, so you go up to 2, The slope is up 1 over 1. There's that line. And then the other one, I would say, is the best to graph with x and y intercepts. So the x-intercept, put a 0 in for that. So x-intercept is 2. The y-intercept, you can put a 0 in for the x. Y-intercept, connect the dots, they cross, boom, right there. At 0, 2, if you had to say what the solution was. They don't ask for that on this one, but that's what it would be. Okay, the elimination method, it would be the best for this one here because it's perfect. You could add them together and the y's would eliminate right off the bat. Okay, if you want to find the y coordinate, then we're going to just do elimination, cancel these out. So that would be 10x equals 10, and then x would be 1, but then we're going to have to go and plug it in somewhere. So I probably would put it in right in that top equation. So that would be 4 times 1 plus 3y equals negative 5. 4 plus 3y equals negative 5. Subtract 4. 3y equals negative 9. Adding these together, or subtracting them, however you want to say them. Divide by 3, so we'd have y is negative 3. So D. Most straightforward for this one. You could debate probably both of these, but this one makes the most sense the way it's worded. The graphical method, because both equations are in y equals mx plus b form. This one says the substitution method because you can easily solve one equation for a variable. That doesn't make sense because they're already solved for both variables. So because of the wording, it doesn't make sense. But I would say substitution is a good way to do that as well. Okay, which one correctly demonstrates the process of elimination? Well, they all look like they're making an attempt to do it, but I see this one as showing it correctly and this one. So both of these. I don't see a mistake with this one. What they did was they multiplied by, they're trying to eliminate the y's, so they multiplied the bottom equation by negative 1. So you can see negative 12x, that would make that negative 2y, that would make this negative 26. And then if you added these together, the y's would eliminate, you would add these. So that would be negative 15x, this would be negative 15. So x would be 1, check, I see that one good. This one, if you wanted to do it, you could, it looks like they multiplied the top equation by 4. So let's see if that's correct. Multiply the top equation by 4, that would be negative 12x plus 8y plus 44. Add these together, the x's would eliminate. This would be 10y equals, this looks like 70. So this looks good as well. Check. These other ones have issues. This one looks like they made this 9x, which doesn't help at all. They multiplied by 3, which doesn't cancel anything out. So, and they show that it does. So, no good. This one, there's a mistake. They didn't multiply this side of the equation. They just multiplied the left side. So, no good. So put 1 and 2 actually for this one, A and B. Okay, this one has a problem. I worked it out. It doesn't make sense with this dollar amount. So change the dollar amount to $730. Then it's good. So the system that you want to set up for a problem like this is it says it's 180 tickets. So x plus y equals 180 tickets. And what you want to do is kind of state what each variable is for. So maybe I'll say that x equals the adult tickets, and then y equals the student tickets. It's the number of student tickets, the number of adult tickets. Okay, I'm just trying to save a little little time. Okay, the first equation would be $6. So $6 times the number of tickets plus $3.50 times the number of student tickets equals the total new dollar amount, $730. If I want to solve this, I've got to, I lost my little, there we go. I got to use either substitution or elimination. So I would use elimination. So I could multiply this equation by -6, and that would make it -6x. And this top equation would be -6y, and then this would be -1080. That's what these two multiplied together would be. So let me get rid of this line, because the two that I actually want to add together are these ones. Because now they will have opposites. Notice the x's are opposites, so we can now add these together. So the x's would cancel out, and this would give -2.5y, and these add together, that would be -350, and then divide by -2.5. So that would be, comes out to be 140, and that would be 140 student tickets. They asked for adult tickets, and so you can tell that if you know x plus y equals 180, then you know you have 40 tickets left over to be adult tickets, so that would be 40. Or if you need to actually plug it in, you can, so that would be x plus 140 equals 180, and subtract 140, x equals 40 adult tickets. Last couple. 39, which one's the correct graph? It's this one here, and that's because of, test points. Really all the lines look all about the same. You could do a test point of 0, 0, and you can plug it in here and see if it works. So you could do 0 is greater than 0 plus 1, and that is false. And I'm looking at this line right here, and I see that 0, 0 is false, so I don't want to shade that side, so I would shade this direction. And then the other one, I could do a test point, and it would be 0 is greater than -1, and that is, that's true. And so I'm looking at a y-intercept of -1, down 1 over 1, so I'm looking at this dotted line. And this time, it's true. So if this is the line, and 0, 0 actually does work, then I want to shade the side that has 0, 0 in it, so they come together in that region. 40. Okay, we're looking for just an ordered pair that's somewhere in this shaded region. So the one that is in the shaded region is 1, 1. It's actually just right there, but it's on a solid line, so it's good, it counts. If there was ever an ordered pair that was on a dotted line, then it would not count as part of the solution. You can also take the 1 and 1 and put it in to each of these, and it should satisfy both of the inequalities. Okay, bonus question. I want to solve this one, so I'm going to distribute. So this would be -56, and then we have negative times a negative, so that would be plus 7 radical 5 plus 9 radical 5. Now notice that these are both radical 5s, so you're allowed to add them. You can add and subtract what's called like radical expressions. So this is -56, and you just have to add or subtract the numbers in front. So 7 plus 9 is 16. 16 radical 5. So this is your best answer, simplified. And that is it. Good luck.